Hello, everyone. How you doing? Thanks for sticking around to the end of a conference. It's often very tiring. Who here's got a sore head from the amount of stuff they've been learning? I know I have. And drinking. Okay, so there's the learning part. Who here's got a sore head from drinking? More of you. Makes sense. Well, thanks for coming along. I want to talk to you today about fine-grained access control. I kind of gave it away in the title, so hopefully you're not going to be surprised by today's talk. But some of us have heard about access control mechanisms, and they're evolving over time, so I'm going to go through a bit of a background, and then we'll look at what ReBAC, or relationship-based access control, is and how it helps. But before we start, why am I here talking to you? I've been a software engineer since 1999. I actually used to put the number of years up there that I've been a software engineer, and then I felt really old recently. So I decided to change that. So I've been a software engineer since 1999. I'm big into security and privacy. I love sharing and learning from the community. So I've been kind of involved in the community for quite a while. And then about 5-6 years ago, I started out as a developer advocate for a security company. And then about 5-6 months ago, I'm losing track of time already, I started working for Sonar. So if you've ever heard of SonarLint, SonarCube, that's the company. This talk is not about that at all. But if you want to talk to me about that afterwards, feel free to come and find me. So yeah, I've been there for about 5 or 6 months now. I'm also on what used to be called Twitter. Ben Dechrai, my DMs are open. If you want to contact me, that's usually the best way of doing it. I'm also on the Blue Sky thing at ben.sc. I don't check that as often. If you're not on Blue Sky and you want to be on Blue Sky, come along and persuade me afterwards that you're actually a nice, genuine human being, and I've got some invite codes for you. So, enough about me. Access Control 101, understanding the basics. So let's just have a quick look back at two of the most prominent forms of access control before we look at ReBAC and why that is so different and why it helps us out. So the first one, actually before we go into that, I just want to get some kind of taxonomy of the kind of diagrams we're going to be seeing today. So we're going to see entities. Entities are things that want access to stuff. And we're going to see resources. Resources are things that entities want access to. And as we'll see later, resources can also be entities. And then we have rules. Rules are things that stop entities or allow entities getting access to these resources. Now, normally in these kind of diagrams, you're probably used to having like stick figures representing people, but I find that people are unreliable, as I'm sure you will all agree. So I thought I should definitely use a dog for this, because dogs are never going to run around and desert you. They will stick with you till the end of time and do exactly what is meant to be done. They will follow the rules. So let's have a look at RBAC first. This is probably the access control model you've probably heard of before. It's probably the most simple one. Access control, role-based access control, is based on the idea of having roles, hence the name. And roles you can think of kind of like hats. What kind of hat are you wearing today? Sometimes it might be multiple hats, sometimes there's one hat, sometimes you leave your hat at home, or your wallet at home and then you can't get on the train. Different roles have different names, and each of those will then have access control assigned to them. And like I said, you could have one hat, you could have multiple hats. I don't trust this dog as far as I can throw it, so I'm not going to give him admin privileges. But this dog is an employee of ours, and we're going to define some rules around that. Now, this door is basically going to say if you've got an orange, a green, or a blue hat, then you've got access to the bone. In this case, Robo Shadow here, that's the name of this dog, has access, so door opens and Shadow's very happy and starts chomping on a bone. Attribute-based access control takes it one step further. Role-based access control is very simple, as you can see, but if you want to model anything harder, it becomes very complicated very quickly, and then it's hard to work out in your head what's actually going on. So attribute access control came along as a way of solving this. It's kind of like a little bit like role-based, but there are other things you can look at as well. Attribute-based access control is based on attributes, and attributes could, in this case, be, is this dog a service dog? Is it a good boy, loyal, or fierce? And in our case, we know that this dog is very loyal, as all dogs are, except the fierce ones. Anyway, we have a loyal dog here, and the door says, if you're a good boy or a loyal dog, you can have access to the bone. If any of you think I'm being cruel and not allowing this service dog to eat the bone, it's because service dogs are working dogs, and you don't eat while you work. As soon as they're no longer a service dog, they'll probably be a loyal dog, or a good boy, probably not fierce, so they'll be able to have the bone. However, we have a second check on here, because we've got extra attributes we want to look at. So maybe we say, between the hours of 9 in the morning and 9 in the evening, this door can be unlocked. Because how many of you have dogs? About half. How many of you let your dog sleep in your bedroom? I've got one person. No, absolutely not. Never. If you do let your dog sleep in the bedroom, how would you feel about the dog waking you up at 3 o'clock in the morning, chewing on that bone? So we're going to put an attribute check in here. We want to make sure that the time is the right time for them to be able to get access. So in this case, poor RoboShadow here doesn't get, actually this is a different dog. This is RoboMin. Dali generated all these dogs for me because I'm really bad at drawing pictures. But access control attributes can be based on other things as well. Maybe it's our identity. Maybe it's the current weather. Can't think of a good example of why that will be. Maybe you don't want to be able to unlock a door during a thunderstorm. Maybe it's your location. Maybe it's based on the way you authenticated. Maybe if you've done a single-factor authentication, you can't do it, but multi-factor you can. Or maybe it's based on which network. Are you in the office? Are you connected via VPN? Or are you connected via a really dodgy Wi-Fi at the cafe? So all of these can be attributes that come into ABAC in order to decide whether or not somebody should have access to something. So that brings us on to relationship-based access control, which is orders of magnitude different. It doesn't even relate in the same way. It's a very different way of thinking about it. Has anybody ever heard of, actually no, we'll get onto that in a second. Diagram of how ReBAC works first. So we've now got a dog. I am a dog. Dali made me. Therefore, it must be a dog. If the internet says it's true, then it's true. Anyway, we have another dog here, and this dog has an owner. So we have this owner relationship. The owner is a mad scientist, but that's okay. He probably designed this dog, I'm guessing. This owner has a friend. Friend is a farmer. It's an unlikely relationship, but it's been a long relationship. They've been through a lot together. And this farmer has a lot of sheep. I think you can see where this is going. One of these sheep was delicious. And from that, we get a bone. To the vegans and vegetarians in the room, I apologize. So we can model this relationship, and now we can infer access based on that relationship existing. So as you can tell from, let's just zoom in a little bit. As you can tell from this, we can now define the entity that we want to define rules around. Rather than looking at the dog, which is what we were looking at before, the dog is an admin or the dog is loyal. We're now looking at the bone. What can be done to the bone? And in this case, we've got an action to eat. We've decided that the animal's owner can eat the bone, the animal's owner friend can eat the bone, or the animal's owner's friend's pet can eat the bone. And if we follow those lines, we will see that this presumably dog has access to the bone because of that relationship. If the mad scientist and the farmer break friends, the dog no longer has access to the bone. We haven't had to change any permissions on the bone or on the dog, but that relationship breaks and access is now revoked. There we go. So, I want to take you under the hood of how ReBAC works. It's not necessarily 100% necessary for you to know this, but I find as a developer that if I understand how something works, I'm going to be more easily able to use it. Rather than working on a black box and just having an API to talk to it, sometimes it's nice to know what's going on inside. I guess looking at the bones of the sheep, I mean the meat of the dish, the whatever. So, how does it work under the hood? Has anybody heard of the entity attribute value model before? This is used in, we've got a couple. This is used in ways of designing databases where you don't know what entities you're going to have until you've gone into production already. You might think to yourself, well, that sounds a bit odd. Why would you ever have that? Well, think of a content management system. You have a page, you have an article, you have a comment, you have a user, you have an image, you have sub-content within a page. All of these entities, you might not actually know about them until it's gone into production and you want to define a new entity. So the entity attribute value model allows you to do this. Rather than having a user table and an article table and a comments table, you have an entities table. And this defines all of the entities in your system. In this case, we're going to have a user and an article. Then you have the attributes table, which looks like a mess, but it does actually make sense. It's a little confusing because instance ID is 1 often, but yet you'll notice on the right-hand side we've got a username, a password, a title, and content, and they don't feel like they fit with the same kind of element. And if you look on the second table, you'll see that they are actually part of 2 different entities. Entity ID 1 is a user, entity ID 2 is an article. And then we can construct some really complicated SQL. which is not actually that complicated, but it can get even more complicated, especially once you've got different kinds of attributes and lookups and stuff, and depending on what you're looking up as well. So in this case, we're going to select the attribute and the value from the entities table and the attributes table, where the attribute instance ID is 1. So I've got that in purple there, and you can see that's in purple on the screen. So we're looking at instance ID 1 of an article. This, if you had a simple article table, would be select star from article where ID equals 1. But because we've made this more generic, it's a little more complicated. So from here, we can get the results that we've got a title, ReBAC for the win, and content Ken has FGA. You could also do some different kind of looks up where you say, well, get me all the users. So you don't want just the attribute article, the attribute username, where the entity ID is 1. So this is going to give you all the usernames in the table. So it's more than one entity being returned. You can then also, at some point in the future, say, you know what, we're going to add some comments into the blog, or whatever it is we've written. And rather than having to create a comments table and having to push changes out to your databases and do all those kind of tests, you just say, well, I'm just going to add another row into the entities table. And say, well, we now have an entity called comment. And now you can add a whole lot of extra information into the attribute value table to say, okay, we've got a comment. It's going to be entity ID 3, because that's the comment, instance 1, because this is comment number 1, and we've got an article ID that we're linking to. So now we've got that relationship between them. We've got an article ID. Sam wrote a comment on today at 3 p.m., about 8 minutes ago, and he just said first, because he's hilarious. So this is how the EAV table works, and it is fundamental to kind of understanding how the relationship-based access control model works as well. Let's start with an entities table, because we're still looking at entities. Now, the difference between EAV is it's all about the attributes and the values, because you actually want to pull values out, like the content or the image of a blog post. But in relationships, we don't really care about the content, we care about the permissions. So it's a slight variation of the EAV model. You have an entities table, and let's say we have Robin, a user. We've got Acme Co., the best company in the world to work for, and ReBAC for the win, the best blog title ever invented. And then we're going to have a relationship table where we define relationships between all of these entities. So in the first case, we want subject entity ID to be 1, that's Robin, and the object to be 3, that's the article, and the relationship type is owner. So this is basically defining that Robin is the owner of the article. Maybe we want to make Robin a member of the organization. We can do some more interesting stuff with that later. And maybe we've added another user to the system, Morgan, and they are also going to be a member of the organization. And finally, and this is where it starts getting fun, we're going to define a relationship between the organization and the article, but with a entity relation dependency. So here we're saying that the organization, too, as a subject, has the ability to view entity ID 3, which is the article. So we're now saying Acme can read the article, but that doesn't really make sense. Like a company can't read an article. But we're putting a dependency over here of member. And we're saying if somebody is a member of the organization, they can read the article, and that's where this member in the relationship type comes in. So now we're extrapolating relationships of relationships. And that's all very well, but we still don't have any permissions. So let's add a permission table in. First one we're going to put in is relationship ID 1 is the first line down here. So we know that subject entity 1 and object entity 3, so that is Robin, in relation to the article, should have read permission. So we put a permission type of read. We also want Robin to have write permission. And then what we're going to do is create a read permission for relationship ID 4, which is this bottom one here. So if we extrapolate that, that's basically saying that any member of an organization called Acme Co. can read the article. Now, note very specifically that Morgan has not been given implicit access to this document. So let's query the ReBAC model now to work out what's going on, what permissions different entities have in the system. So let's say we want to find everybody who has write permission on the article. So we do this cross lookup, and we say, okay, find all the permissions that say write. We highlight those. Then find all the entities where the object is the article. Who can write to this article, or update it, or make changes to it? Now, in the first line, both of them match up. So we know that that's a hit. The fourth line, the permission is obviously not read, So the fourth line there is actually invalid. We're not going to consider that one because both checks do not exist. We want to have the read permission on the article, and the fourth line is not the read permission, so we ignore it. So there's only one permission that lines up with who can read the article. And if we look up the subject entity ID, we can see that's Robin. So by querying the ReBAC system, I'm not going to go into the SQL because that's going to be even worse than the EAV model. But by querying the ReBAC system, you can say, hey, who can read this article? It's going to say Robin can. Now let's have a look at write. I've been saying read all the time, and I meant write. Imagine the last 4 minutes didn't happen, replay it in your head, and do a string substitution and replace read with write. Excellent, thank you. So Robin can write to the article. Let's find out who can read the article. So again, we've highlighted the relationships that are read relationships. And now we're going to highlight all the object entities that are the article that we want to read. And in this case, both of them align. So we already know that in the first instance, that's user number 1, and Robin can also read the article as well as writing the article. But we see on this line here that subject entity ID 2, the organization, can also read the article. But we have the qualifier over here of member. Now, we don't actually need to care whether or not it's Acme Co or whatever. We don't need to look that up. What we can do is just take the subject entity ID and the the entity relation, and we can use that to look up all the other elements in the relationships table, thus, and say, okay, we'll find if the organization member can read it, then any member of the organization can read it. So we're basically just doing a second lookup, saying, okay, now look up everywhere where 2 is in the object and member is in the relationship type. And now we can see that subject entity ID 1 has read permissions, but of course we already know that because Robin is already highlighted, but also subject entity ID 4, which is Morgan. It's a long, convoluted way of getting it through, but within 3 tables now, we've managed to define all the relationships that could exist between multiple entities. And remember, down here, you've got organizations and members, but you could have that multi-stacked. You could have an organization that has a drive. You can have a drive that has a folder. You can have a folder that has members. And each of those would be multiple lookups. So some of these lookups can get quite complicated. But it's a great way of modeling permissions in a very complicated way that gives you a lot of flexibility around how to define whether or not an entity has access to another entity. So the implementation details, let's have a look at these. Let's say we want to allow editing of an article. We want to allow them if they're an admin or an editor. But if they are an editor, they can only edit this particular article. If the article is sensitive, then they must be on site, and also it must be during office hours. This would be a great thing to do in government or high secrecy organizations, intelligence organizations, anywhere like that. If you're writing a blog post, it probably doesn't matter. They probably wouldn't be treated as sensitive. So in that case, it would have to be an admin or an editor where the editor is allowed to edit that particular article. How would we do this currently if we didn't have relationship-based access control? We'd probably write some code that looks a little bit like this. And then we would have to fill in the rest. Let's do that. So we want to make sure the user is an admin or is an editor. So that's fairly straightforward. But if they're an editor, they also have to be in the list of editors for that document. That's pretty cool. Also, it cannot be a sensitive document. But if it is, then we need to do some more checks. We want to grab the user location and make sure they're on premises. And we want to grab the user location and make sure that it is office hours. Now, this is all pseudocode. But in case you're wondering why office hours is on the location, it's because if I'm in Geneva, it's going to be a different office hours to if I'm in Austin. So depending on the office, you might have different opening hours. Also probably helps with things like public holidays. It just came to me. You're welcome. So if we wanted to change this, it's probably going to be a bit of a headache. I mean, it is fairly straightforward, but imagine you've got this bit of code in one area that stops access to documents based on certain rules. And if you decided that you were going to change those rules, then you'd have to change this code. But you've then got to do a lot of regression testing. Is that going to affect articles or documents that you don't actually want to have affected by this? Is it going to change the way that certain people can access things from certain offices? What happens if you have a work from home policy all of a sudden? How does that change things like office hours? Does each home have its own office? So it becomes really complicated to start breaking the not breaking, expanding the rule sets on which access is authorized when it's baked into your business logic. Ideally, you'd break that out into a separate coroutine or a function, but then you're calling that from multiple places, and that makes it even more confusing to work out, well, if I change this here, what is it actually affecting in my application? So let's instead define the relationship and the access control on the objects themselves using relationship-based access control. So we start off with an entity type document. And this entity is going to have two relations. One is an owner and one is an editor. And in this case, an owner is any user. Now, you might think to yourself, well, I don't want every user to be an owner. But remember, this is just defining the relationship. It doesn't say that every user is an owner. It just means that the owner is an entity type user. And then later on, you can say, okay, well, this particular user is the owner. And in terms of the organization, we have here, the editor, we have the members of an organization. So if you're a member of an organization, then you can be an editor of this. Which particular members, you define later. This is basically a schema for what you're storing. And again, this is pseudocode. Depending on the type of ReBAC product you're using, it's going to be a little different. But we have a definition here of a document. Now, normally you'd probably also have some actions in here, but for space saving, we're just going to have a look at the next one, which is the sensitive document, which is basically a document with some extra rules on top of it. So for document, you probably have an action saying, look, you can edit it if you are an owner or an editor, and that'd be fairly straightforward. In this case, we're going to relate this sensitive document to a document so that it inherits all the bits above. So the sensitive document now has an owner and an editor. And we're going to define the action edit. Who can edit a sensitive document? So we've already defined that we want it to be within working hours, and you can define functions in most ReBAC systems. So you could plug that in and find the information out of the user to find out whether or not they're within working hours. But we also know that there's more than just that on top of that. We want to know whether or not the document has an owner. In other words, is the current person we're looking at the owner of the document? And if so, are they currently on premises? Or is the current person looking at it an editor of the document? And if so, are they on premises? So this now is defining pretty much exactly what we had on the previous slide. And is defined specifically for the sensitive document type, which now means that when you go in and you change these rules, you know I'm changing the rules for sensitive document, which means that applies to every document. You don't need to worry about the business model, the business logic anymore, because that's all hidden away inside your relationship-based access control platform. So what does the code look like? If this was the code before, we can now extrapolate all of that out and say, you know what, I just want to know, can the user edit this document? Much easier to read when you're looking at your code. It's cleaner, it's more maintainable. You're going to be able to work across teams and understand exactly what's going on without having to dig into the documentation. And if you find there's an issue with the access control, you look at the access control, not the business logic. So some use cases of where this might be useful. We've already seen a very good one, which is document sharing. And as I mentioned, you could add layers in there, like documents can be in folders, and folders can be in drives, and drives can be owned by organizations or maybe even departments. So there's a lot you can do with document access control. Other things you can do is hospital patient records. It's very similar. You've got different kind of people who have different access to different things. But in this case, it's interesting to note how relationship-based access control helps you with revoking access, which is one of the most important things I believe that ReBAC gives you. Because it's based on relationships, you don't have to. You know, when somebody leaves a company, there's usually a sheet, and some person in IT has to go through and make sure they're removed from Active Directory and they're moved from this and that and the other. What if you could simplify a lot of that just by having rules defined? So the nurse can access the patient's record while they're assigned to that case, but as soon as they're taken off that case, they don't have access to the documents anymore because the relationship is broken. You don't have to modify the access control for the document because that's reliant on the nurse being on that case. Similarly, you might have corporate calendar access. Who here has an executive assistant? I don't. But if I did, that executive assistant would have access to my calendar. But as soon as that executive assistant is no longer my executive assistant, either they stole too many cookies and I had to let them go, or maybe they've been reassigned to somebody else. That relationship is broken and access is now revoked without having to go through and make specific changes to that person's permission systems. Or project management systems. I think you can see where we're going here. You can update a task. Now, this one's interesting because not only can the task no longer be updated by you if you're taken off the team, but if the task is moved to a different project, then you don't have access to it either. So that's really cool. You don't have to think about those things anymore. The final one I'll give you is the social media platforms where a person can like or read a post if they are friends with the poster, but as soon as they forget to invite their friend to their birthday, the friend unfriends them and now access is denied. That might be a bit too personal. So I don't want to just mouth on to you about how these things work, but hopefully that underlying table framework has given you an idea of exactly how the lookups work. So you can see the benefits of one relationship breaking and the whole chain of the lookup just falls down, which means that automatically the access is just revoked. But there's nothing better than a demo to see how these things work. So let me hope this all works. I have chosen, in fact, let me just switch back to this real quickly. There are a number of solution providers that I've looked into. I haven't tried them all. The one that I've chosen to go with here is Permify. And the reason why I've chosen that is I do believe they probably have some kind of business model under the hood. I mean, it doesn't make much sense to start a SaaS company if you don't. But this is actually a totally open source project as well. So you can download it, run it in your own environment, which is what I have running on my laptop. The others I haven't necessarily tried. I played with OpenFGA a little bit last year. I've heard some good things about OSO and Asserto, but the others, that doesn't mean the others aren't any good. I just haven't looked at them. But there are some ideas for you to have a look at. That's one slide too far. Let's switch over here. So I've got Asserto running in the background, Permify rather. Got this running in the background, and you'll see, if I can find my mouse, there it is. This is currently listening. Let's make this bigger. Full screen. So you'll see on the right-hand side here, it's actually got a gRPC and an HTTP server, and that's essentially all this is. You make definitions, it's got an API. There's no pretty front end to this. Maybe that's something they'll offer as a paid service. But you can download this and run this on your own machine, stick it in on a cloud service that you host, and it'll provide you a gRPC and an HTTP endpoint in order to make requests to both supply a schema, add data in, and then also do the check at the end to see can so-and-so do X, Y, and Z. So I've got this running in the background. I've got a whole lot of Postman. I've got a collection here, and this is at postman.com/Ben-Dechrai. If you want to go and play with it, there's a link on my thank you slide, so don't worry about remembering that. But if you want to run, I keep forgetting which one is called Permify. It's up there for me. My brain, I tell you. If you want to run Permify and just run these against your local system, the Postman collection is there for you if you want to play with it. So let's start at the beginning and list the tenants. So as with a lot of software as a service type products or self-hosted products, you can actually tenantize this. I don't know if that's actually a word, but it should be. So you can have multiple tenants, which are basically sandboxed areas of data. So if you defined a schema and some entities and some permissions in this tenant, you create another tenant, they'd be totally separate, but they're running on one instance of Permify. So at the moment, if we run this, we will see that we have no tenants, ideally. If we do, we don't. Excellent. So I did remember to restart Permify before the talk, which is often something I forget to do. So we have no tenants yet at the moment. So let's go ahead and create one. It's very simple. I'm basically going to create one called T1. That seems to be a standard, or not a standard within the industry, but it's a convention that Permify use. So I'm going to call it T1 for tenant 1. And because Sam was so witty and clever, I'm going to copy his comment. I'm going to call this one first. So let's go in and click send. And we get a response there saying, yep, we've got tenant T1, the time that it was created, and the name. So we've got that response back, confirmation the tenant's been created. Let's just go back to list tenants and double check that's been done. And we can now see that the tenant has been created. So now we've got a space to add our schema and our rules into. So let's create the schema. Now, this schema, as you can tell, is very pretty and really easy to read. Yeah, Phil's squinting. I don't know if you're squinting because it's too small or because it's not easy to... So I've done us all a favor, including me. And put down here. So basically, it wants to take just a long string with the /ns for the carriage returns. I don't know why they've chosen to do that, but hey, that was their choice. So this is what it actually looks like if you break it out. We're going to create a schema where there's an entity user. We're not going to stick any kind of attributes in there. We've got an organization, and as seen in some of the previous slides, we've got relations between them. So we've got an admin and a member. They are both users. And then we've got a document, and the document has an owner, which is a user. It has a parent, which is the organization. And then it's got a maintainer, which is a user or a member of the organization, which means that technically a document could be maintained by somebody outside of the organization as well. And then we've got our actions down at the bottom here. So you can view it if you're an owner or a member of the parent. So that'd be like where the document sits in the folder. Or if you're a maintainer, or if you're an admin of the parent. Actually, the parent in this case would be the organization, because we can see that in the line a couple above. And then so that's to view. To edit, you need to be an owner, maintainer, or an admin of the organization. And to delete it, you need to be an owner or an admin of the organization. Kind of pretty standard rules for document access. So let's hit submit on this. And we should get a response back, hopefully telling you we've got a 200 OK. And here we have a schema version. So every time you update the schema, you get a different version back, which is kind of interesting because you can actually use that schema version in future requests and say, hey, I want to make this request for whether or not somebody can do it based on this schema. If you don't provide a schema, it'll use the latest one, which is kind of cool. So let's now read the schema back. You can see in here that I have actually taken the schema version. So Postman, if you don't know, allows you to run scripts before and after you make requests. So on the previous request, I actually grabbed that schema version, put it into memory, and now we're going to paste that back in there. So I don't have to do copying and pasting, because doing that in demos is never going to make anything go wrong. So we're making a request, and also when I created the tenant, T1 got put into tenant ID. So in the URL at the top there, you can see the tenant ID. Anyway, that's more a Postman thing than a ReBAC thing. But if we sent this request now, we should see the schema has come through, slightly more nicely formatted than a long text string. We can see that we've got a document. We can see their relations. There's a maintainer called maintainer. It's kind of nice and obvious. Relationships, we can see that there's a relationship to a user and also a relationship to an organization where that relation is a member. So we're getting that information back out, which means that in our application, if we wanted to get information about the relationships, we can do that and then render it in whatever we want to our users. That we've got the owner is a user, we've got a parent, which is the organization, etc. There's a lot of stuff in here. And it's basically just defining exactly what we just put into the schema. All right, so the next thing we want to do is create some relationships. So in here, I'm going to create relationships by passing a number of tuples in. So in this case, I want to create a relationship between organization 1. Now, in the table, I had an entity, what was the terminology? There was the subject and the object, thank you. So the subject is the person, the object is the thing they want access to, and then you've got the relationship type. In this case, it's slightly the other way around. You can see the subject is at the bottom, and this is a convention that I just took from Permify. I didn't want to change it because this is what you will get. See, I find it easier to read from bottom to top. So a user is an admin of organization 1. A user number 2 is a member of organization 1. And then here's a little bit more. So anybody who's a member of organization 1 is a maintainer of document 1. Does that make sense? So that's why that member, the relationship type and the link to the member relationship comes in that we had in the fourth table example. So a member of organization 1, if you didn't have that relationship there, you would be saying that organization 1 is a maintainer of the document. But in this particular case, we're looking one level further and saying members of that organization. And then I'm going to say that user 1 is the owner of document 1. I think that's it. So let's hit send. And then we'll read all those relationships back. Oh, before we do that, let's just go back to this one. So you'll see down here there's a snap token. This is also generally optional. You might need to provide it in some of the requests you make. Basically what this is, it's almost like a snapshot, a token for the snapshot of what's just happened. And this, I've not looked into too much within Permify's libraries, but this is one thing they use to enable caching. So I was saying before, when you've got multiple levels of relationship, you're going to get some really complicated lookups. We had to do 2 lookups to find members of an organization. But what if you have to find members of an organization that have access to a parent, that have access to a document, that have access to, etc.? You're going to have a lot of lookups there, so it can become really valuable to cache these, and Permify uses this snap token as part of its caching model. At least that's one of the aspects of it. So let's read all the relationships back. You can see here that I'm actually not passing a snap token in, because in this case, we want the latest snapshot of the data. But it does allow you to look at previous snapshots as well. So if we look at this, we should see that all the information comes back out. We've got user 1 as an admin of organization. We've got user 2 as a member of organization. So all of that has come back out. We now know that that is inside the ReBAC system. So this is where it starts getting a little bit more interesting. We can do things like reading all member relationships. This is something we didn't really program in, but we can get the system to produce the relationships between different entities that are extrapolated out of the data that we put in. And then from there, we can now start checking the user permissions. So let's have a quick look at what this does. We are basically going to go in and say, does user 1 have view permission on document 1? Can anybody remember the data we put in? Do they? We get a response. Check result allowed. I don't even see that at the bottom. Let me just make this a bit taller again. So we've got check result allowed, and we've got a check count of 2. That's basically how many checks it had to do in order to be able to determine that. So if we do something like, can they access document 2? I might be breaking my own demo at this point because denied. I haven't actually tried changing the document ID because we've only got 1 document. Never try something you haven't tried before in a demo. But it worked this time. So document 2 doesn't even exist. And it's like, no, you can't access that because you've never told me anything about it. But if we change it back to looking at a different screen while you're typing is always fun. Change it back here, and let's say, does document 1 have delete? And it's allowed because user 1 is the owner. If we change this to, does user 2 have delete access? It's going to come back denied, because user 2 is the member of the organization who only has read access. So making a very simple request like this is doing all of that nasty, deep database diving into the ReBAC model, the way it stores all that data, to come back to you with a very simple yes or no. It's very cool. Another thing you can get out of here, not that I would recommend that this is a way of organizing your document management system, but you can go through and say, hey, I've told you about all the permissions for documents, so tell me about all the documents. So let's do a lookup here, and I say I want to find all documents, but in this case, I only want to find the ones that user 1 can view. And if I hit send on here, we can see the document 1 is the document that user 1 can view. If I change this to edit, that's also 1. Let's see what document user 1 or user 2 can edit. It's also got a 1. Does it have a delete? It comes back empty, because user 2 does not have access to delete any of the documents. So this is a nice way, if you're doing a document management system, to say, show me all of the files that I manage. You could actually just use your permission system to give you that information without even having to look at your data. Probably then want to look up that data as well, so you can actually show it what title it is, because if somebody said, do you want to edit document 74? I can't remember which one that was. So the other thing you can do is go through and list users. So in this case, I want to find all users that can delete the document. In this case, that's just going to be user 1. But if we want to find all users that can view the document, that's going to send us all those users. So as an administrator, or maybe when you're using Google Docs, for example, and you click on the share button, it tells you who can read the document. That would be a great way of getting that information out. And then finally, you can do something like get permissions. So in this case, we want to find out what permissions user 1 has on a document. We don't know whether they can, we don't care whether they can read or write. We want it for a report of some sort. So what permissions does user 1 have? They have delete, edit, and from are all allowed. And if we change that to user 2, we can see that it shows us all of the permissions that the system knows about, but it'll actually also tell you whether or not it's allowed or denied. So you're getting that full list with a Boolean value rather than just a list of the allowed permissions. Cool. All right. Well, I believe that wraps up the demo. So I hope that's been useful. I hope you've got an appreciation for what relationship-based access control actually do, the kinds of places you can use it. It's not perfect for everything. There are going to be situations like, who here's got like one of those $100 home routers for connecting to the internet, and you type in admin and the password is admin? Who has not changed the password? Come see me afterwards. But in that case, relationship-based access control is really not worthwhile. In that case, role-based access control will be perfect. Does this person have admin rights or not? You can have multiple users, but you don't really care whether or not that user's dog had a good day. In some cases, you're going to want to know what time of day it is, but you don't need to go through the hassle of the relationship-based access control. You just need to put that in as an attribute on the attribute-based access control. But in some cases, it's really powerful to use relationships, and relationship-based access control is probably going to be the solution you want for that. So I hope that's been useful. Thank you for your time. If you have any questions, I'm around for the rest of the day. Thank you. And in case it wasn't obvious, there's the URL to the Postman collection if you want it.